Morning. How is your Sunday? Enjoy. What's going on? Hmm? How did you do P1 past papers? What about your breakfast? And so, who is not with us? Tinuka is not. And who else? Tinus. Shiranga. Shiranga, what's about your bro? Okay, let's. So, okay, he's also back here. Today we are doing mechanics. Get ready with your mechanic books. So we are going to end mechanics today. As soon as we end mechanics, you can leave. Okay. So if you can finish the everything within half an hour, we are good to go. If it takes like 5 hours, then you are also good to go. Okay, let's do this. So what did we discuss last day? We talked about the new concept called what? Something like moments. I asked you to not to confuse this with momentum. This is momentum means mass into velocity. This is not that. This is what? This is how do we define the momentum? Sorry, moment around the point. The rotational effect. If we take a force of let's say 5 Newton is acting 3 meters away from an object perpendicular distance. So we can get the moment around that point by 3 into 5 or simply force times the perpendicular distance. F into d, moment equals F into t. This is a very simple lesson. Okay, not even hard as I would say. What did we do? Integration. Integration was also a very easy lesson for us. So this is even simpler than that. This makes a lot of sense as well. So let's try to do it. Okay. I think we did the part one, introduction part, and only thing I didn't do was question number 5. Hope you did it. Okay. Okay, what is in the question number 5? After that, I will jump into the next section. There is a point, and they say this is some sort of I ask you to do this at home. This is a force going. This force F is creating a moment of how much? 15 Newton meters around this point P. And this point P is 12 meters away and 30 degrees apart from here. So they are asking the magnitude F. So simply you can take M. M should be equals to F times D. So what you have to do? You have to find this F. How can you find it? So simply we can write moment they have given 15 Newton meters equals force times distance R. Do we take this 12 meters? No, we have to take the perpendicular distance. How can we take the perpendicular distance? From the trigonometry, from very simple trigonometry, you should know this is equal to opposite side. So 12 meters times sine 30. 12 sine 30. So sine 30 again, it's a known value. How much? Sine 30 means half. So if equals 12 into half, so this becomes 6. Then you divide both sides by 6. So you get here 5 over 2. So F equals 2.5 newtons. So here, so remember that the data given. So when you first read it, they say F produces a moment of 15 Newton meters. If you read it with little less consciousness, what do you feel? This force is 15 Newtons. That's how you are going to feel. But it is not the case. Force is not given. The given data point is the momentum. Sorry, moment. Okay. Okay. Now, what if there are more than one force? Let's say we have a downward force of 3 meters away, 5 newtons, and here 7 newtons, which is let's say 5 meters away. So how can you calculate the resultant or the total momentum around this point? Easy. What to do? I told you moment has a direction. So what you have to do? Get the moment around this point M. You can either go clockwise or anti-clockwise. Now I feel like this has a very large momentum compared to this, so I take this way. It's never matter. You can get it clockwise as well. So I am calculating anti-clockwise momentum. It is equal to around P. So 7 times 5, and this is coming other way. So you have to take, if it is the given momentum is against the given considered direction, so you can take it as negative. So it's minus 5 times, so it's going to be 35 minus 15, so it will be 20 Newton meter. So what is the resultant of this? This is the resultant moment around the point P. Very simple thing. Okay. So if the things are not in the direction that you consider, make them as negative. Okay, let's finish. Finish. Do everything in 8B. Quickly do 8B. I would definitely say P1 and M1. All of you can take A's. Okay. All of you can take A's if you do 5 past papers. That's all. They are really simple. Okay. If you are saying you can't take A, that means you don't have a will to take A. That's all. Okay. Because the questions are not going to deepen. Okay. P2 you have to work a little bit. If you work a little bit, you can take. That means I'm talking about P1 and M1. You don't need to do a very hard work. Okay. It's very simple questions you have to do. You see, you saw how the integration ended. Only differentiation there was like finding that perpendicular lines and tangent lines, equation finding little bit related with straight line, that's all. Nothing else is like going having so many complicated questions. P2 you need a little bit of effort because yeah, but P1 and M1 you can definitely with a little effort you can do. So P2 also I'm not saying you can't, okay. So comparatively the easiest. Oh, sorry. If you are getting less something less than M, but my thinking is you haven't done anything other than the things we discussed in the class. Okay. Yeah, just kidding. You have to do work. Okay. Okay. So I say B. Part A. The diagram shows the sets of forces acting upon a light rod. In each case, calculate the resultant moment around P. Easy. Let's do them. Please comment if you don't get or if you can't understand any. Okay. Now, for the first two only, I will draw some force diagrams. 3 newtons, 1 meter. And this is 3 meters and 2 newtons. Resultant moment about P. P is here. So how can we? So around P, I am taking which direction? I am going to consider upward. feels like the lengthy force is here, so I am calculating this way. So I can take this 2 newtons into how much total length is 4. Actually, you don't need units in the first. So, and these and clockwise are negative. So 3 into so how much? 8 minus 3, 5 Newton meters. This other moment is 5 Newton meters. Question number 1. Sorry, B. Part B. What is part B? There are so many things. So P is here. 3 newtons down here. And 2 newtons from here. And 4 newtons from here. So this length is P 1 and 2. So I am again taking from P. Which direction? I feel like these are a little bit larger. So I am taking a clockwise direction. So around P, what is going to be the resultant moment? So this 4 into how much? 4 into 3. And this 2, what about this 2? It is working other way, this direction. So it should be negative. This is this way, this is this way. So minus 2 into 1. And what about this 3? So it's same effect as 4. 3 also going downward. Like this. Okay, so it is going to be about 3 into 1.
What is it? What? मैं वहाँ क्लास से कौन ना देंगे पा बनी से पा वहाँ क्लास से कौन ना
Okay, no, come on again. Okay. 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 Don't say no to foods. Okay. How much? 3 into 1. How much is it? So 4 into 3, 12. 12 minus 2, 10. 10 plus 3, 13 Newton meters. Okay. You should have responded. I was waiting for something more rough. Then it's already in the recording, so we could have some online, make some video about online classes. Like how will it like if you scold the maths teacher while being thinking you are ignorant, I can't understand anything what this person or something like that. And you can actually do it, pretend it like you don't know it, no? Yeah. Okay, part C. Quickly do this. You can do all. So 3 Newton, 7 Newton, and P. 1, 1, 2. So, which direction I am going to calculate? I am taking clockwise. So, this is 4 into 2. 4 into 2. Here, how much? Minus the 3 is against what? Which direction? Anti-clockwise. Sorry, clockwise. So, it is 3 into 1 plus again 7 into 2. 7 is in our direction. So, 8 minus 35 plus 14, 19 Newton meters. So for the rest, I am not going to draw the graphs. Is it making sense? I think so. How is it, Viranga? Do you get it? So 2 minus 1, so it's going to be 14 minus 11 Newton meters. Eight. What's wrong? I feel like it is correct. Yes, 18. 19. What is it? What's the change about it? Shiranga. How much you got? Nope. See? Now I took this direction. That's a good question, by the way. See? Now, see? About P. So around where? Consider the point. P is point here. Now when I take this anti-clockwise as positive direction, so 4 it's making this direction. So if you go around, this is also the same direction. 7 Newton is also same direction, but this 3 is the other way around. Okay. So E. What about E? So always you have to consider the positive and negative. Sometimes, okay, this might be hard to catch for some of you because you might wonder how I put this plus and minus. So what you have to think? Around which point I am talking always. So depending on the point, the plus and minus signs change. Okay. So be very careful. So everything. I am going to go again this direction anti-clockwise. So what do we have? 4 into 1 minus 3 into 2 minus 2 into 3 minus, sorry, it's plus 1 into 4. How much are we taking? 8, 12. So minus 4 Newton meters. So if I need to positive, so it's going to be clockwise direction 4 Newton meters. In the book, always they have used this as clockwise 4 Newton meters. They are writing like that. So in the paper, as a practice, you write it clockwise. Okay, this is clockwise. For the easiness, I am using this direction because when I was doing my A levels for the local syllabus, we didn't use clockwise or anti-clockwise in words. We just denote it with this arrowhead. But what I feel is for the Excel, we have to write whether it is clockwise or anti-clockwise. So make sure you write clockwise in the end or anti-clockwise in the end. Okay, I will write. You also start using it. E. Plus and minus signs change according to what? According to the direction I am trying to take. Like you don't need to do the same way. Think I am going to do this. If I take this last same question, E in the clockwise mode. If I calculated this in the clockwise direction, so I have to take this as minus 4 into 1 plus 3 into 2. Again, here it will be plus 2 into 3 minus 1 into 4. Like that. These two forces will be minus if I begin the other way. Okay, so please make sure you don't get confused. So it's best you told me that you are getting confused. So try to nail it again. Okay, the part C. I will do the part C again, not B and E because it's already drawn here. Okay, look at the part P, point P here. I'm going to do it now. At first, I calculated it. What? Anti-clockwise. Here we can do the same question clockwise. See, I'm doing it clockwise. You don't need to always take the same direction that I take. But if you apply the correct theory, in the end the answers will be same. See, I can take this way clockwise. I'm going to calculate the resultant moment clockwise. So this is acting other way. So it's going to take it as minus 4 into 2. What about 3 newtons here? It's in our direction. So you have to put plus 3 into 1. And what about this 7? It's also negative. So negative 7 into 2. So we have minus 8 plus 3 minus 14. So we have minus 22. So we got minus 19 Newton meters. So it is in the clockwise direction. It is how much? It is negative 19 Newton meters. So anti-clockwise we can write. So around P anti-clockwise. What is the? It's going to be plus 19 Newton meters. So only thing actually you have to worry in this lesson is identifying a direction without getting any errors. Beyond that is really simple. Okay, E, F, last one, F. Another point F, I am going to calculate clockwise, sorry anti-clockwise. So around P, I am calculating in this direction. What do I take? What I am going to take? So I have this 1 Newtons here, it is negative. So I'm going from the left hand to right. So 2 Newton is positive, 2 into 2 minus 1 into 1. This again 2 is minus. So this minus 2 into 1 plus 3 into, so it's going to be 4 and 6, 10, 10 minus 3. 10 minus 3, 7. So 7 Newton meters. So it's, you can write 7 Newton meters anti-clockwise. Okay. Anti-clockwise. Still any of you confused with identifying the positive and negative directions? Please let me know. So number 2. What is in the question number 2? Okay. Easy part A. What you have to do? Around P, I can take. I'm going to take clockwise direction. So I have these 2 newtons into 5 meters. So 2 newtons into 5 because the perpendicular distance is 5 and minus, so no, 3 newtons is also same effect. So it will be how much? 3 newtons into 2. So we have 10 plus 6, 16 Newton meters. What about the part B? Question number 2, part B. Now, in these questions, earlier questions, all of the forces were, what happened to all the forces? They were, they look like in the same axis, no? Now these are in two different axes. It's like this is a two-dimensional situation. So how can we deal? Even though you didn't realize, all the other cases were also two-dimensional. So the same thing. Do you need to worry about these two forces? Considering them as a new situation. No. So simply take which way I'm going to take. I'm going to take anti-clockwise direction. You are free to take any direction. So I'm going to take this 3 newtons. So it's going to be 3 into 3. And what about this 4 newtons? It is clockwise. So it means minus 4 into 2. So 9 minus 2, it is 1 Newton meters. And actually, what is the direction? Anti-clockwise. Okay. So for the easiness, I will write AC. Okay. AC means what? Anti-clockwise. Okay. For ACL. Okay. It's not argon and chlorine. ACL. Or not even ACL cable. Question number 3. Do it. Do those two quickly. What is it about the question number 3? They say around this point P, the resultant moment is 17 Newton meters. So if you calculate the resultant moment around this P in the clockwise direction, so you have to consider the direction. See the clockwise direction. How much are they talking? The resultant moment is 17 Newton meters. And they are asking the length B. So you can equalize. When you find from all of these, you can calculate, no? How much is going to be? This 5 into 3, this negative. Oh, no, it's positive, no? So 5 into 3 clockwise. What about this 4? It is anti-clockwise. So you can take minus 4 into 5. And what about 2? It's also positive. So 2 into, you don't know the actual distance. So you can write 2 into, what is the total distance? It's going to be 2 plus b. Sorry, 5 plus b. 5 plus b. And the resultant is equal to how much? They say when you get the resultant in the clockwise direction, it should be equal to 17. How did I write it? That's the data point. So we have to solve this equation. How much are we going to write? Write 50 minus 20 plus, then how much? We have here 10 plus 2d, no? Okay, 10 plus 2d equals 70. So it's going to be, we have 25, 5 plus 2d is equal to 17. So it's going to be d equals 6 meters. How much is d? D is going to be 6 meters. If you have d only like this, you will have a resultant moment of how much? 17 Newton meters. Question number 4. You don't need to draw these graphs. So when you are dealing, you just take another point. Here, 12, 3, 4, 4, 20x. And here we have 3x. And again 2x. And this is 6. Okay, very similar question to question number 3. What you have to do? Resultant moment, they are talking, it is 12.8. Find the value of x. And this 12.8 is again clockwise. So if you calculate around P in this direction, all the total momentum is going to be equal to our 12.8. Very similar to question number 3. What you have to do here? So you can take how much? You can take this 12 into x. Perpendicular distance is x. And then what about this 4? It is anti-clockwise, but it is 4x. So minus 4 into 4x. Total distance, we have to always consider the total distance. And what about this 6? It's again going to be plus 6 into how much total distance? It's going to be 6x. And sum of all these resultants is equal to 12.8. 12.8. So you can quickly solve for x now. Now you get 12x minus 16x. So minus 4x from these two plus 36. 36 minus 4. So 32x is equal to 12.8. So you can both sides divide by 32. This, like if you think these are 128, you can easily take the answer. 428 it's 4. So x is going to be how much? 0.4 meters. Anyone else got the same answer? Oh, why did I wrote it as 4? I have been mixed up with the compromise with the earlier question. Sorry about that. This is 10, no? Stands for noting down. This is 10. This is not 4. It's going to be 10. So it's 12x, 36, 48, 48, and 40. It's going to be 8. It's going to be 8. So 128 again. If you think it as 128, it will be better, right? How many 8s are there in 128? Going to be 16, 1.6. Answer will be 1.6. Is it clear? Okay, you can use the calculator if you need. Quickly, we don't have all the day. Already half an hour gone, like 40, just half an hour. Okay, shall we jump into the next part? Everything clear? So we need to clarify the things we learned here, but we need these things for the features part. So if you don't understand any, please let me know. Okay, now we are in 8.3 equilibrium. What is it? We are going to talk about equilibrium. This one it's not new to you. We did so many questions in this. So when something is in equilibrium, what will we take? Like say this is some object in the ground. And let's say we are applying a force of 4 newtons from this side. Let's assume this as a rough plate. But we say this is in equilibrium, it's not moving. So then what you can, if you draw the forces acting upon this one, we know there will be some mass will be down here, and there will be a reaction upward, and there will be a frictional force acting upon this one. So we learn those things. So now what's going to happen? If we say this object is in equilibrium, if we resolve forces in any direction, whether it is horizontal or vertical, what do we do? We take the resultant force is always equal to 0. We resolve forces in any desired direction and we took those as 0. So here what we can do, but we have to understand. We can understand that that's a theory. There can't be net forces acting upon the given object if the object is in equilibrium. So when we are dealing with moment forces also, what's going to happen? Moments also, the resultant moment should be equal to 0 if the object is in equilibrium. If the object is not moving, it is still, but we can understand the resultant moment should be equal to 0. That's all. Okay, please have a note of this one. Why it's being paused. Okay, please write 8.3 equilibrium and make this as a note. When a rigid body is in equilibrium, the resultant force of in any direction is 0 newtons, and the resultant moment about any point also is 0 newton meters. Please write it. Hope you have finished writing it. Okay, now everyone look at the board. Now I have demonstrated a model here. What is the model? There are two supports. Okay, there are two supports, and those supports I have named as A and C. Okay, this is a uniform rod. Okay, uniform rod. Which kind of rod? Uniform rod on these two supports. Okay, support A and B, and the total length is 8 meters of the rod. And these supports are, if you take these as B dash and A dash ends, these are supported at 1 meter from A dash end and 3 meters from B dash end. So since this is a rod, this has a mass. Let's take the mass is 10 newtons. Okay, I would say mass is 10 newtons. Since the given rod is, if we say it is uniform, you can always take the mass, the total concentrated mass is acting where? It's acting in the middle. So this rod is 8 meters long, so we know it's going to be middle. You can mark that way 10 newtons. Always you can mark if the rod is uniform. So we have to deal with the not uniform rods also. But if you see this one uniform, you can get the weight of the rod is acting in the middle downward. Okay, then what do we have? If we draw all the forces here, we can forces acting upon this rod. There will be a force coming on B here, RB, and there will be another support from A. I am writing it as RA. Now, if I say this rod is in equilibrium, okay, I'm going to say this rod is in equilibrium. So when the rod is in equilibrium, what do we know? We know the resultant forces should be zero and resultant moment also zero. I ask you to find these reactions at A and B. The reactions from A and B on the rod. How can we find it? If we resolve forces vertically up, what are the things going to come? RA plus RB, but this is minus 10 is downward. Minus 10 is equal to 0. So we can get RA plus RB is equal to how much? Equal to 10. But can we find anything? Oh, can't, right? We have two unknown terms. Can we find one? No, we can't find one by only considering resolving forces vertically. If we horizontally resolve, there will be no forces in any, no? So how can we find A and B? Now, with the knowledge of, with the help of moments, what we can do? Now think what's going to happen. You can take moment around any point and equalize to zero, right? The rod is in equilibrium. For the rod, I am going to take moments around this point A. Why? Let's see why is that. Why I am taking around that point. Why do I take around A here? Let's see. Let's take moments around A. I'm going to take, I need to find B. So I'm going to take moments around A. In the anti-clockwise direction. So let's see what are the forces coming. What force come from here? This RB forces is going to come. So RB into how much the distance is going to be? Since this is the midpoint, this value will be 3 here. Sorry, it is given, it's 4, no? It's already 4. So, but we need the closing. So RB into length is 4. And what about this 10 newtons? The length is 3 and it's minus. So minus 10 into 3. What about RA? RA is going through point A. So the perpendicular distance will be 0. So there is no effect for the moment for this point. So that part is not going to come. Anyway, the total should be equal to how much? 0. So try to understand the logic here. What is the logic? The object is in equilibrium. I am saying you it is in equilibrium. So you can always equalize the resultant moment to 0. So you can find RB here. So how much is RB is going to be? So it's going to be minus 30 divided goes to the other side plus 30. So 30 divided by 4. It's going to be 7.5. How much? 7.5 Newton. Support from B is 7.5. If you want to find support from A, you can do now in two ways. Either you can substitute in this equation or you can take moments around B. I'm going to take clockwise moments around B. So what do I get? R A into again 4 minus this 10 into 1. The distance between the B and the weight is 1. So it's going to be 0. So you can find that RA will be equal to 10 divided by 4, 2.5. See, it will be the same answer you got if you substitute here. Now you have more than enough knowledge to find these situations. Okay, start the exercise 8C. 8C. 8C, I will do question number 1. I'll write the questions that I'm going to do here. Okay. 8C. I'll do 1 to everything. 1, 2, everything. Then question number 6 and 7 I will do. Then 7, 9 and challenge. 1, 2, 7, 9 and challenge. From 8C, I will be doing question number 1, 2, 7, 9 and challenge question. Please do give priority to this question. Only difference. So what is the point that was added to? Now today we learned two new things. What are those things? Last day we learned what is moment. Moment means the force into the effect of a force, the rotational effect of a force. How to calculate it? Force times the magnitude of the force into perpendicular distance. And today we learned how to get the resultant force. When there are more than one force, we take them as vectors, no direction. We consider the direction, is clockwise or anti-clockwise. So depending on the direction that we are going to choose, we can either take plus or minus. It doesn't matter. Then now we learn if the object is in equilibrium, that resultant force we can always equalize to 0. Now see, here is upon other theory. Those are the points you have to understand. The object is in equilibrium, the resultant is 0. So I will help you with the first one. What is the question number 1? going to be 1A. Draw it quickly. What do we have here? They are giving us two supports C and D, and the rod is A and B. And what are they talking? AB is a uniform rod of 5 meters length, and all the lengths are also given 1, 3, and 1 here. Weight is 20 newtons. If the rod is uniform, we can understand it's acting right in the middle. So it should be how much? 20 newtons. AB is resting on a horizontal position on support C and D. In each case, the magnitude of the reaction. Find the magnitude of the reaction from C and D. So let's mark them as, we can mark them as how much? RD and this as R3. Now, when you are doing these questions, try to figure out the notations as well. How to write down those without any confusion. How can you find this RC and RD? You can simply take moments around C and D now. I'm going to take around C. What do I get? If I get anti-clockwise moments around D, so there's the object. The rod is at rest. It's not going to move. So that's in another sense you can understand this is in equilibrium. So if I take clockwise anti-clockwise moments RD, what is this length will be? 3, no? This total length is 3 from C to D. Going to be RD into 3. What about 20? It's other direction minus clockwise. And what is this length? It's 3 divided by 2. That means 1.5 plus 0 by the produce in rest. So you can find RD is equal to 30 divided by 3, 10 Newton. Easy. Now, if you resolve process upward, you can find RC. Or if you take moments around D also, you can find. I'm going to take clockwise moments around D. What do I get? R3 times 3 minus again 20 times 1.5 is equal to 0. Again, you will find R equal 10 Newton. Now, this is a symmetrical situation also. So, RC and RB both are same. So, clear? Now, get on with all the questions. Question number 1, question number 2, then 7, 9, and challenge. I'll be offline for 5 minutes, so do it quickly yourself, okay? But offline mean I will be just muted. How did I get this 1.5 length? See, the total distance is 3 from here to here. They have given this length is 3. But we need from this point how much will be this length? From this point how much will be this length? I can take, because the total length is 5. This is the 20 acting on the middle. So this is 3 divided by 2. Going to be 3 divided by 2, which is equal to 1.5. Here also it will be how much? 1.5. I needed from this point how much will be there. From this point how much will be there. Okay, please work on it. See anyone who didn't do the part B yet? Please let me know. Anyone who could not do part B? Or if you got the answers, please comment. Please comment your answers for RC and RD. That means I need to check whether you can do this or not. I assume you will be able to do this. That's why I'm asking. Okay, to find D, the reaction from D, support from D, I make them as RDF. First thing is you have to identify from this center here, 20 newtons, what will be the length? RD to 2, the length is 2, times minus 20 to 5. So it's going to be 10 divided by 2. Reaction for support from D is going to be equal to 5 newtons. And if you resolve forces vertically upward now, you can have RC plus RB minus 20 is equal to 0. So you know already RD should be equal to 20 minus 5, which is 50 newtons. Oh, this is one way. I will do the other way as well. What is the other way? You can take moments around D. So when you take moment around D, you can, I'm going to take clockwise. So RC times 2 minus 20 times, what is the distance? 1.5 equals 0. Why? Is in equilibrium. So you can have RC equals how much? 30 divided by 2, 15. See, it doesn't matter which theory you are using. If it is the correct theory, you can have the correct answer. Dinesh, you got the same answer? Did you? Part B. Question number 1, part B. Subway, is it clear? Okay, so what? RC and RD? 8C, question number 1. Part B. I got 12.6. I think sometimes we have gone like ACBD. Is that all? But 12 point something. BB. B. Okay, thank you both. for RD and RC. Think when you take in the direction where RD is positive, it's always easy, no? Like if you take, I am going to take anti-clockwise around C, RD will come as negative. So I have made something negative. It's little bit one step of more, no? So RD into 2.5 minus 20 into 1 is equal to C. 20 divided by 2.5. Like 8 newtons. To resolve now, RD plus RC is equal to 20. C is equal to 20 minus 8. Now you can see, if you notice here, when the support that is much closer to the mass or the weight center of the load has to give more support than the other support. No? So those are little understanding you should get. When the support becomes closer to midpoint of the rod, it has to give a higher support than the other one. Hello. For part D, you can have RD, support at D is 7.4 and the reaction support at C is 12.6. Nimitar, did you get those answers? Now, can we come to a deal? What is the deal? Tomorrow, I am not going to do classes. That's the deal. Because I have to get my second dose vaccine. Hopefully, there is no strike. So, let's do that also today. Okay? That's the deal. Anyone needs to go exactly at 12? Is there anyone who needs to leave exactly at 12? If you have, please let me know. Okay, if any of you have a trouble, that means we have some planned work after 12, right after 12, let me know. Like we will do around 12:30, 12:40, something like that, okay? So, what is part two? In each of these diagrams, shows a light rod in equilibrium horizontal positions under the action of set of forces. Okay, find the values of the unknown forces and the distances. So you have x and y, 1, 2, 1. Okay, what is the diagram here? We got two forces. One is T. Here we got 10 newtons. At 1 meter we have x. And 2, okay, we have y. We need to find. Okay, when we are solving this, it's always easy to get which direction. Pick up a point that other force will not come. So if I pick up around this point x, the action of point of x here, what's going to happen? Only y will come as the unknown term if I take moment. So I'm going to take moments around x. And we know what are they saying? The light rod. Light rod means we don't need to see the data points. This is a light rod, so there is no weight. So they say it is in equilibrium. So we know in any direction if we resolve forces, sum is going to be 0 and moment also going to be 0. So if we take around x, I will get, what do I get? y into 2 minus 15 into 3. Here 10 is also positive. See, okay, be careful about the sign. 10 into 1 should be 0. So it's going to be y equals here minus 15 plus 10. So 5 divided by 2. It's going to be 2.5 Newton. What about x? So you can find x. I'm going to resolve forces upward. Easy. When you find one, so you can easily find the other one by resolving. For resolve upward, x plus y minus 10 minus 15 should be equal to 0. So x plus 2.5 minus 5 should be equal to 0. So x equals also how much? Should be also equal to kind of. Is it correct? I feel like it is wrong. Something is wrong. What's wrong? This is also minus 15, huh? Minus 15. So it's going to be minus 25. So x equals 22.5. See, around which point do I should take? I'm going to name this point as A, B, C, D. Which point? You can take moments around any point and equalize to 0, but I am going to pick either C or D. Why? You can either take A or B as well, but I know both x and y, then I have to build another equation and by taking from another point and solve two simultaneous equations. Rather than doing that, I am always trying to take moments in such a way that I can cancel off one of the forces. So I am going to take moments around C. So I will have only x, not y. Y is not going to come. So if I take moments around C clockwise, I will have x into 1. Here this 15 also plus, so also clockwise. So 15 into 2. This 20 is minus. It's going to be minus 20 into 3. So you can see x is equal to 30 and this is 60. So it's going to be 30 newtons. Now if you resolve upward, y plus 15 minus x plus 20 is 0. So y plus 15 minus 30 plus this is also minus 20 plus 0. So y is equal to how much? 15 minus 15, 45, no? Sorry, 35. 35 newtons. Last one of part C, question number 2. Last one, part C. All the forces are given in G, so your answers for X and D will come. D will be meters, but X will come in. X will come in G. Okay. So if you resolve now, see for this one, think if you're going to get now if I make these points A, B, C, D, and E, if you resolve forces or if you get the moments around D, you can see this. You can find D actually. Only D will come. If you take resolve forces upward, you can easily find X. So I'm going to first find X by resolving forces upward. So X plus 5 minus 5 minus 10 minus 50 is equal to 0. So now X is equal to how much? 25G. So this 5G, 5G, 10G, 15G. So answer for X equals how much? 25 times G. What about now? Since you have found X, you can take moments around any point. And anyway, I'm going to take around D, right? If I get this answer wrong, sorry, value for X is wrong, it doesn't going to affect for me to find the length D. So it's going to be how much? If I take clockwise moments around D, 15 into D minus 10 into 3 plus 5G into 5 minus 5G into how much total it does? 4 to 2 to 4, 4 plus 3, 7. Everything is equal to 0. So it's going to be 15 times D. So it is actually 15G, 15GT. I forgot where G is. So now you can see, you can divide everything by G. G is not going to come. Because G's are coming all the terms, so you can cancel out. So 15 times B, here we have minus 30 plus 25 minus 35. So minus 10 minus 4. So 15D is equal to 40. D is equal to 40 divided by 15. Both you can divide by 5, so you get 8 over 3 meters. Question number 7. What do we have for 7? So for the question number 7, what are the what are all the forces acting? So you have to model this first. Draw all the forces. If you can't draw the forces, game is over. So what are the forces? There are two tensions. A and sorry, A and they are A and C. Now this rod is attached. How much? And this is hanging with two wires. So the tension in the wire at C is 4 times the tension at wire A. So if you take this as TA and this is as TC, so they have given us TC is equal to 4 times TA. You can take it. Or if you just wrote TA here, you can write it as 4TC. That way also you can write it. Okay. And you know there will be a, since the uniform is rod is uniform, you can take this weight. What is the weight? 40 kilograms. So 40 kilograms. So it is 40 into G, 40 G newtons downward. Find the tension of the wire at C. How can we take it? Now if you resolve forces vertically up, you can easily find C. No? Say TC plus TA minus 40G should be equal to 0. Why? They say the rod is in equilibrium. It's not. There is no net forces. So TA you can TC you can write in terms of how much TA. So 4 times TA plus TA is equal to how much? 40G. So TA equals how much? This much divided by 5. It's going to be 8G. So TC is equal to 4 into 8G, which is equal to 32G. You can substitute to G as 9.8. So how much you get? 32 into 9.8. We get 390. So 314 newtons. Okay. Then what about, they are asking about something else also. What else they are asking? The distance from A to C. What is the distance from A to C? How we were able to find this TC at once? By, I mean, if we actually think how many unknowns are there? There are 3 unknowns. But how could we found this TA, DC and this distance also we don't know. If we take that distance x, now how could we find it at once? Because they have given the data that this tension is 4 times the tension at A. Now how can we calculate the distance CB? They are asking the distance CB. So let's not take this as x, let's take this length CB length as x. How can we find it? What to do? You can simply get moments around B. Then you will find it because we already know TC and TG. So I am going to take around B. I am going to take clockwise moments. So I have TC times X minus 40 times. It's going to be in the middle. So it's going to be how much? 2.5. Total length is 5. So this length will be how much? 2.5. So minus 40 into 2.5. So it is 40G. 40G into 2.5. And what about this? There TA is also going to come. It's also clockwise. So TA plus TA into how much? Total distance is 5. Is equal to 0. While this is in equilibrium. So we have to find this x here, the length of CD. TC we can substitute. How much we got? 32G times x minus 40 G into 2.5. Here we have plus 8G into 5. So G is available. The gravitational acceleration is available in all. What you can do? You can just cancel it off everything by G. So you will have 32x minus how much it's going to be 60, no? 60. Here we have plus 40. So x will be equals to 20 divided by 3t2. So it's like 5 over 8. How much is 5 over 8? 5 over 8 is going to be 0.625 meters. 0.625 meters. Anyone else got the same answer? Please comment for the question number 7. The length CB equals 0.625. Sunal, did you get the answer? Okay, easy questions. See, these exam type of questions, they are not really hard. Oh, wait. I think question number 7, I did something very wrong. I did something very wrong, very wrong. They say there is a particle attached to B, okay? So in the question number 7, I think I missed something very terribly. I just saw it. So please, I am not going to do the board question again, but you can cover it from question number 7. See, some of you said that you got the same answer. But what about the tensions? I think it will be wrong. TC and TA, they are not correct the way that I took it. Because there is another particle hanging. Okay? Look at the question number 9. Look at the question number 9. What do we have? Uh, I am repeating again. I think question number 7 is wrong because I have missed some of the weights. So, they say, what are they saying in the question number 9? A particle of weight 30 Newton is attached to here. There is another weight. How much is it? It's going to be 30 Newton. So you have to mark it. You have to at that it's going to be 30 newtons here. And the weight is acting in the middle, it is W. What else they talking? Show that the tension of the wire attached C is so they are asking to find this TC in terms of W. Okay, in terms of W. How to do that? Part A is you can easily do. If you take moments around A, only TC will be the unknown term. Then we can easily find it. Or the other lengths also we know. So if we take around A, why do I take around A? Because this tension is not going to come. See these logic points. So I can take PC times 4.5 minus whatever this weight is halfway through. Why since the rod is uniform, you can take it is acting in the middle. So minus W into 4 minus this 30 also. How much? It's going to be uh, 8 meters like 8 meters. So that's all the three forces will be here. What do we get? So if we make TC as the subject, we get TC equals 4W plus here we have 240 divided by 4.5. Here also 4.5. If you look at the answer, what do we have? We have 8 over 9 and 160 over 3. So you can actually consider this 4.5 as 9 divided by 2. Here also 9 divided by 2. If you take the reciprocals, you will have how much? EW over 9. I think 160 over 3 will come. Yes. And part B, what is part B? Find in terms of W the tension in the wire attached to beam at A. Now, in terms of W, they are asking TA also. What we can do? We can use this value to find it. If you resolve forces upward, what do you get? TA plus TC minus W minus 30 is equal to 0. So you can easily keep A is equal to, rather than gating moments, this method is easy. Why? We don't need to deal with the lengths. So W plus 30 minus this one. 8W over 9 plus 100. So this total thing, no? 160 over 3. How much are we taking? So we have W over 9 minus 10 over 3. If you take a common denominator and solve this, you will have like this, okay? W over 9, 150 minus 160. Oh no, it's going to be minus 80. Minus 80, no? 150 minus 160. No, 90 minus 160. Will be minus 70. Minus 70 over 3 newtons. This will be the tension of A. Yes, Sabri, thank you. Then Then what do we get? Given that the tension in the wire attached to the beam at C is 12 times the tension of the wire. If this TA is 12 times, C, the tension at C is 12 times this much, they are asking the value of W. Easy, what we have to do? You can write TC should be equals to 12 times TA. So some of you might accidentally write TA equals 12 times TC, which is totally wrong. Don't do it. Okay. So what we can write? 8W over 9 plus 160 over 3 is equal to 12 times 9W. Oh, sorry. W over 9 minus 70 over. So we can cancel up the denominator, it will be easy. If I multiply everything by 9, I get 8W here. Here I have 116 to 3, 408 equals, here we got 12W and 12 will be cancelled out, 12 into 70 into 3. It's going to be a little bit larger value. So how much we take W term to one side and others to the other side? We have 4W is equal to 480 plus 36 into 70. So then you ultimately you have to divide that by 4. So you will have a value for W. How much did you get for W? Please comment your answers. I got 750 newtons. Very nice answer. It looks like that. Huh? Anyone else? Navita, did you get the same answer? Okay. What about the challenge? Do the challenge question. I gave it since it looks like nice. Now what is the challenge? Hmm, challenge we got after a long time we are doing some sort of a challenge question. You can think 6 equal lengths. 1, 2, 4, 5, 2, 3, 4, 5, and 6. Okay. This is hanging from this one here, and after this comes down. I'm putting square weights because it's easy to draw rather than blocks. No, we don't have anything here. And one here and one here. Okay, like this. What are they talking? In this one, they are asking. The diagram shows a kinetic sculpture made from hanging the rods. The distances between the mark each rod are equal. Arrange 1, 2, 3, 4, 5 to mark squares using each one so that the sculpture hangs in equilibrium and the rods are horizontal. So it's like we have to put 1, 2, 3, 4, 5, all of these, and this can't tilt. How can I put? So it's like balancing, no? See, moments are balancing. So even a grade 5 student will be able to do this. Think. Let's try to do it. We have to think separately on two rods. It will be the easiest way, no? Now sum of the total moments for these should be equal to sum of the total moments from here. And these two also will be equal to this one. Let's take this length as always XO unit length. I take this one length as unit one, so easy for me to calculate. Okay. To put the point here is I need to put 1, 2, 3, 4, 5. So let's say if I put 1 and 2 here, will 3 be substitution will be easy, right? Why do I go for substitution is already the values are given to us. If I have 1 and 2 here, it's going to get 3 and totally it's not going to work. What to do? That's a good one. I also don't know what to do now. Let's try to pick it up. Think. Okay, Dinesh got already answered. Dinesh saying put 4 and 1 here and 5 here. Let's see if you put 4 here, 4 into 2 will be 8, 9. No, this is not balanced. Even 4, 1, 5, it's not balanced. No? 5 into 1, 5, 1, and I'm trying to simplify the smaller one here. Do I get, what about if I change this? If I change this, here 1, 4, 1 plus 8, 9, it's not going to work. Here 1 and 4, 4 plus 2, 6, it's not going to be balanced. Now I say we got 6 here, so what to do? Can't do it. What about 1, 2, 3 here? If I put 2 and 1 and 5 here, it looks like balanced. This is 2 into 2 will be 4, 1 into 1 will be 1, and this is balanced 2, 1. 2, 1, 5 is balanced here. Now let's check here. Actually, this might be sometime easy if you have some symbols for this one and work on it. Okay. If you think in terms of tensions, it will be easy sometimes. I don't know. Let's see. For this one, how much? Now we got the total tension. What is the total? It's like it's going to be, if we resolve the forces, this tension here is going to be same as here. So it will be 2 plus 1, 3, and 5, 8. So we have a total of 2 into 8 in this side. How can we do this way here, this side here? Now I balance this one. I have to put 3 and 4 to this only. So how can I put 3 and 4 in a way that we can balance it? If you put 3 here and 4 here, 16 I have to make. So it looks like it's not making. What if I put 4 here and 3 here? 9, 3 into 3, 9, 9 plus 4, 13. It's not working. If I change 4 here, 4 into 3, 12, 12 plus 3, 15. It's closer, it's not even working. So it's not a perfect model. Let's see. Let's see. Your answers. Who got the answer? 1, 2, 4 in the right. 1, 2, 4. One, two, 4. 2 into 1, 2. 1 into 2, 2. Now it is balanced, no? Yeah, 1, 2, 4 will be correct here. Then total will be how much? 7. Total will be 7. So 7 into 2. We have to balance by 14 here. How can we build 14? 14. Where can we put 3 and 5? We put 5 here, it's going to be 15. No, it's not going to work. We put 5 here, 3 here. 3 into, yes, very good, correct. Okay, with the help of students, we can nail it. Now see, did you understand how we did it? We tried to balance. Always we calculate the length versus mass to its counterweight into length into mass. So this will be now 3, 5, 1, 2, and 4. From left to right, 3, 5, 1, 2, and 4. Thank you. Is it clear to everyone? Masha? These questions, like when you are even a kid, you can do, not try this. How can I balance this? Even without knowing single thing about momentum. Okay, let's jump into last part today. I will be not going to tilting part, but I will give it just jumping into 8.4 plus we will carry this lesson to one more day. So tilting I will do next day, but tilting is finished. Okay, we do 1 hour more. It's exactly we can finish the lesson, but anyway we will do only 8.4. Let's keep a bit for the next day. Sometimes this center now, so far in the questions we give, what did we have? We had all the rods were uniform. Now you can be given non-uniform rods. So you will be able to find the center of mass or some other things depending on the data set given. Now nothing changes in theory, only thing is not it will be not be uniform. So sometimes you will have to decide where the weight is going to come down depending on the situation. Let's straight away go to some questions. Question number one. Start 8B, question number one. Only 7 questions here. I will discuss 1, 5, 6, 7. Okay? 1, 5, 6, 7. So you can do work on 1, 5, 6, 7, and we are done for today. Last 4 questions. Try to do them. 8D. What to say? A non-uniform AB length weight of how much? 4 meters and weight 6 Newton rest horizontally on 2 supports. Okay, there is something horizontal. For AB non-uniform, length is 4. Okay, we get it. Length is 4. Then what do we have? The supports. Center of the mass of the rod is 2 from A. The A and B are 2 ends. So center of mass was 2.4. It's not exactly in the middle. No? So we can take it as 2.4 from here. And this middle weight is how much? Weight is 6 newtons. And the 2 supports. Find the reactions at 2 supports. The supports are at A and B. So let's assume this at A here is another support and B the other support. Okay. So we have to draw the force diagram like this. RA and RB. I know these supports as RA and RB. How can we calculate this? What is the process? Now we can easily take moments and find those values. No? So if we take rod, get the moments around A, what do you got? RB times 4. Why the total length is 4? Minus 6 times 2.4 is equal to 0. So RB is equal to 6 into 2.4 divided by 4. It's going to be 6 into 0.6 will be 3.6 newtons. To resolve upwards, you have RA plus RB is equal to minus 660. So RA equals 6 minus 3.6, 2.4 newtons. Hope it is clear to everyone. Please do question number 5, 6, 7. I'll give you 5 minutes, okay? 5 minutes, please do 5, 6, 7. Read and do 5, 6, 7. What is in the question number 5? Plant AB has mass of 424 kilograms. A lot of mass. And they say what? The plank is modeled as a uniform rod. Uniform rod. So now you can assume the weight is acting in the center, 24 kilograms. So 24 times G. What else? Find the tension of the rope attached at B. So if this rope, if this is a uniform rod part A, find this tension at B. What you have to do? Just take, I'm going to take which moments? Anti-clockwise moments around point A. Why point A? Because I can cancel off this TA, tension at A. So I will have TB into 4.8 and here 24 into how much? So makes 2.4 left. 2.4, 24G, and here minus 15G into 1.4 is equal to 0. So how much we are going to get? Tension at B is equal to 24G into 2.4 plus 15G into 1.4 divided by 4.8. You can actually substitute for G also when you are getting a final value 9.81. So it's going to be how much? We got 160. 160. If you substitute 9.8, I think it will be much better. Okay, 160. At 160 Newton. Okay, then what to do after that? When a particle of mass 9 kilograms is attached, not that one. Find the distance. No, the pack is now modeled as a non-uniform. So you can't take that 24G is acting in the middle. With new model, the tension of the rod at A is 25 newtons greater than the tension in the rope attached at B. Find the distance of the center of mass. So now what are they talking? This TA, tension at A is 25 newtons larger than TB. For that, actually this A and B are two different situations, so I erase this one. Now we can't take it is acting in the middle, so let's take that as how much? That length. Which length they are asking? the center of mass from A. So I will take that length as X, this length as X now. Okay. And what about the tensions? TA, they say TA is equal to this tension plus TB plus 25. It is greater than 25 newtons. It's greater than 25 newtons. So how to do it? Now, if we resolve upward, we can easily find TB, no? So if we resolve forces upward, we can find TB. TA plus TB minus 15G minus 24G. So it's going to be TA again, you can write in terms of TB. TB plus 25 plus TB is equal to how much? 39G. So we have TB, 2 TB or TB, we can find TB equals 39 into G or 39G minus 25 divided by 2. This value will be the TB value. Then using this, we have to find the length X. If you take the forces, if you get the moments around A, but you will have to get moments around A, you can have what you can have tension of B. I'm going to take around A is anti-clockwise TB into 4.8. TB into 4.8 minus 24G into, we don't know the length, we don't know the center of mass. So I take that length as X minus 1.4, sorry, 15 into 15G into 1.4. That thing, total thing is equal to 0. Why? Even though this is not a non-uniform rod, we can consider the situation as increasing equilibrium. So TB we can actually substitute. How much? 39G minus 25 divided by 2 minus 24GX equals, I take that thing to the other side, 1.4 into 15G. Now G is available. Is it available in every? No. G is not available in all the sums, so we can't actually cancel out G. Today we can make X as the subject. So I will have again 39 into 9.81 minus 25 divided by 2 minus this thing. Actually, I need to take it other side. 15 into 9.81 into 1.4. This total thing we have to divide by 24. What is the value you are taking? Comment to answers how much you got for X. Oh, I got something negative. Is that possible? I got something negative. Where did I went wrong? Please comment to answers for the length. How much you got? So here, I think it will be easy if we went. I got 179. 179 newtons for the tension at B, TB. Then I can take all of these. I will write it again. This is going to be 100 and I didn't forget. I forgot to multiply this with the 4.8. That was where I know. So this is 179 into 4.8. So 179 into 4.8. I got 27. Is it acceptable? No, we can't have 27 again. Somewhere again I have went wrong. Where did I went wrong? Also, you also got 27.21. So it can't be. Something has gone wrong. 24G. 24G, no? So I have to again divide this by 9.81 also. This 24G. 2.77, correct. 2.77. Thank you for your answers. 2.77 meters. Okay, that's great. How we find it. Okay, I think now it will make sense. It's like what to do, no? Getting moments around the required point. So question number 5 and 6 and 7 homework. Sometimes you might have already done it. Okay, I think we did for now more than 2.5 hours. So thank you very much for your support. Any questions on the things we discussed today? Yes, I will upload today. Kiran, I will upload today, okay? And tomorrow, no classes, okay? Please do this yourself. Try to go through the next section also. Tilting part, that's really one little part is adding. So now you are almost, you can do 99% 9 things in the mechanic questions. Only one topic is left. We will discuss it next day. And okay, see you on Tuesday. We don't have, no? Wednesday also I will not be available. Oh my god, what's going to happen? Can we have one in Tuesday afternoon? Extra session. That means because Wednesday I have a planned leave. Okay. Monday, tomorrow also not. Yeah. Tuesday afternoon. Please tell me if you have time on Tuesday afternoon, because Wednesday also I will be not available. Tuesday afternoon, okay? If any of you can't, please let me know. Okay. So thank you very much. See you.